When you develop an embedded project, it's bound to have several sensors, actuators, and other components connected using breadboards and wires. This makes the entire setup quite cumbersome and also prone to errors. Many times, wires just come out of the breadboards or from other components. We end up spending a lot of time on debugging these disconnected wires. This can be a daunting task, even for experienced developers, and certainly a nightmare for beginners. To address this, we've developed a series of project development boards. These boards have been designed in such a way that you can connect most of the common sensors by simply using pairs of RMC wires. RMC stands for Relimate Connector. A Relimate male connector looks like this. There are several RMC pins that are fixed on the dev board. Along with the boards, you'll find several RMC wires. These wires have RMC female terminals on both ends. There are two advantages of using RMC pins and wires. First of all, you will not be able to connect these wires to wrong terminals. The Relimate pin and the wires have notches. The wires will fit into the connector only when you push it in the correct direction. So there is no danger of reversing the polarity or connecting the wires to the wrong point. Second advantage is that you can use regular DuPont wires or header wires if your project requires so. A DuPont female header wire fits in easily into the RMC pin. The IoT Shield for Arduino is an add-on board that sits on top of the Arduino Uno. The dev board has connections from the microcontroller's GPIO pins to several RMC male pins. These pins have been designed such that most of the popular sensors can be interfaced to the board straight away. The Shield also has an IoT module mounted on the PCB. Now wait a minute. There are several Arduino Shields which have a Wi-Fi module. How is this module different? And why do we call it as an IoT module? With a typical Wi-Fi module, you would interface the Arduino board with the Wi-Fi module using AT commands. If you've tried it, you will agree with me about how tricky this can be. And it becomes even more complex if you want to use these AT commands to sync your data with different cloud services. With our boards, all that is history. Your Arduino code can sync with the cloud using simple commands. For example, if you want to set the value of key to a cloud database and read it back, your code could look as simple as this. As you can see here, with just 4 lines of code, 5 lines if I include the hash include statement, I have been able to set value in a cloud real-time database and retrieve the value. Can it get any simpler? We've also marked the name of different sensors on the PCBs. The sensors that are marked are 1. Relay. This connector can be used to connect to a 2-channel relay. 2. An LCD. This is for connecting to the I2C module of an LCD display. PIR to connect to a PIR sensor. IR sensor and Hall sensor. These connectors are to connect to the IR obstacle sensor or the Hall effect sensors. We have one connector for the ultrasound, which is marked as U sound. DHT to connect to the DHT sensor. We have a Relimate connector again. UART for any sensor that uses UART for communication. Push button to connect to a regular push button. SPI is to connect to an SPI device. The pins in our dev board have been configured with the MFRC522 reader in mind. This is an RFID reader and it can be used to build access control projects. Buzz. The buzz connector can be used to connect to a buzzer. And of course we have different analog connectors in the Arduino Shield. So you could have, if you have sensors which give out analog values, you could use these analog connectors. Although the connectors have been marked with the above names, it is not necessary that you must connect only to these sensors. You could also connect the RMC connectors to any sensor which has a similar data pinout. For example, you could use the connector marked as relay to connect to any sensor which uses 5 volts VCC, data 1, data 2 and ground. If you use the relay's RMC connector, then you'll have to use GPIOs D6 and D7 of Arduino Uno. Apart from the RMC connector, we've also provided a 9-pin male header connector. This header breaks out the following GPIO pins: D2, D3, D6, D7, D8, D9, D10, D11, D12 and D13. You may use these pins to connect to any sensor or actuator which does not have a pin configuration that matches the RMC pins on the board. And there are a few jumpers and power connectors on the board. In most cases, you can leave it at the default settings. To understand about these jumpers and the other connectors, please refer to the board's user manuals. Have fun using the WiNoT IoT Development Shield for Arduino.